a video with all the presentation, all the sound, all the chat. Participants can be seen here. If you don't like that, then tell us afterwards, and then we'll remove your name. But for now, I think that should be okay. Otherwise, tell us. Use the chat. It's only the presenters who have get the chance to speak. But if you have questions to them during their presentations, just use the chat and ask questions. Some of the questions I will direct to the speakers after their presentation. Some of them I will save for the panel discussion, and some of them I'll postpone to afterwards. If it's really, really detailed, I think there will be room afterwards. This webinar will have 3-4 presentations. We'll have 3-4 presentations, and then we will have a panel debate between the presenters, and we will have afterwards, and then the 60 minutes is pretty much done. After that, there will be room for question and answering, where you can ask all the detailed questions you have, and we will try our best to answer them. So, with that said, let's have a look at the speakers. You have them here. I'm in top. I'm not that important. But Thomas Østergaard, who's market director at COVI, will give us an introduction to the new trend in district heating network design and answer the question, are there any new trends? Then Peter Yorsel will have 2 presentations, one on total cost of ownership, and the next one, in opposition to the first one, I think I can say, will be called total cost of installation. 2 very different ways of thinking on these really important and very expensive investment you're going to do in your pipe network. Peter is product and academy manager at Lochster. Then Chris, who is the managing director of Lochster UK, will give us an insight into what is happening in the UK. And if some have comments or questions to what is happening in their country, wherever it might be, then we will include that in the panel discussion, and our 3 experts will comment on that. Just to give you a little bit of a cliffhanger, in the end, I will ask the 3 speakers to give their best advice on when you plan your new heating network, what should you actually do? And if you want to share your email address with us, Peter have done an article about pipe nets. That's the whole thing. That's the only thing he more or less works with, I guess. Called Secure the Asset in Your District Heating Network. We will share that article with you when you have shared your email address in the end. You will also be you'll also have our fantastic magazine called Hot and Cool. I think for now that's enough from my side. Thomas, you are on. Here's a nice picture of Thomas so you can see him. And Thomas, please unmute your speaker, your phone, and or your headset. And in a second, the floor is all yours.
Thank you very much. I guess you all can see it now. Good afternoon, everybody, and thanks, Morten, for the introduction. As you said, my name is Thomas Østergaard, and I'm a project and market director for COVI. Short introduction to what I've been doing for the last 33 years is that I've been working with district heating, and for the last 20 years with optimization of district heating networks. So this was very short about me. Now we are going to talk about designing new district heating networks and what is the new trend, if any, in network design. It is so that I think there is. But as you know, district heating is a business with large investments and therefore long investment horizons. Trends are difficult to detect. But one thing is for sure, the talk of the town has changed from looking at all parts or single parts of the energy system to engulf it all. So you have to have what we could call a holistic view on the situation. And I think that is coming in with great impact. A short historical review. When looking at the historical beginning of the district heating networks, district heating was clearly a playground, as you can see, for all kind of experimental entrepreneurs. It was what we could call a Wild West. There were no contracts, no standards, no framework, etc. But as you know, things have changed very much during the last 20 years. A lot of experience has been gained, and district heating has entered into a more controlled and stable environment. We have a lot more knowledge available. So I could mention we have a lot of standards, norms, some legislative frameworks which differs from country to country, contracts, quality assurance, documentation, and so on. So Wild West, it's not Wild West longer, it's a controlled environment, I would say. So today, some other things are coming into the big picture. In spite of our comprehensive knowledge, we are probably standing at a crossroad, and the question is, which road should we take? The climate, the fossil fuels, the green energy, all are parts of the puzzle, but which road to take? And I guess this is something that both is interesting but also worrying us. So we can see what is pushing us against this new situation. And all of you are, well, pretty sure the climate is changing and faster and faster. So this is actually the driving force, I think. The most important, anyway. And we have to find new solutions to save our climate and to save our world, actually. And in this case, district heating is very important, and it's a very important part of the solution. And that is, of course, we, by using district heating, is able to combine a lot of alternative fuels and use them to heat our houses. For sure, electricity is something that is very much up, also in Denmark. But all other things like certified biomass, heat pumps on different sources, wastewater, geothermal energy, you can name a lot of them. So in that way, you also need to have new production units. You need to produce the heat in other ways than before. And that also calls for a change in the distribution of heat. And to add to all that, people all over the world are moving to the cities. So the urbanization is also bringing a lot into this, and I would say that these driving forces actually push us towards what I would call the new trend in district heating, and that is bigger pipes. And we are going to use bigger pipes because we are forced to do it. And I will follow up on this, and I'll tell you something about why we should use bigger pipes when designing new networks. On this slide, I have a typical situation from 3 heating stations at Hofor. And for you who don't know I can tell you that it's a Copenhagen district heating company, and it's a very large company. They are running a very big transmission system, and they have a lot of heating sources. And all of these are fed from different sources, and they deliver heat to the whole network. Their goal, that is to lower the temperature, illustrated by the blue line, to a temperature of 68 degrees. And how should that be possible? For that purpose, I would say, let's take a look at a place where we already did optimization. And this is another Danish district heating network called Skive Fjernvarme, meaning Skive district heating. And we have been doing the optimization of the network temperatures. And you can see here in the beginning, in 2009, we had a forward temperature, or flow temperature of approximately 93 degrees in January, and we had a return temperature of approximately 50 degrees. So the cooling was actually 45 degrees. And this is, of course, a very high temperature, and that was just something they had. They never speculated that they could make that less. But we started the optimization, and you can see here in 2016, the flow temperature had been lowered to approximately 70 degrees. So it was down from approximately 93 to 70. And also the return temperature has gone down to 45 degrees. Very important. Also, the annual cooling of the network, originally it was about 34.1 degree, but now they have changed it, so it is only 24.1, so that's down 10 degrees. So the conclusion on that is that it is possible, it's very possible to lower the temperatures, and this has been done without having very big changes in the network, also without having very big changes in the user installations. The thing is that they were simply using too high temperatures. What you also have to see from this is that we still have a possibility to lower the return temperature. We estimate that the lower return temperature could go as low as 35 or even 30 degrees, depending on the user installations. So let's move on. In big cities, we have this question about the investments. How would it influence the investments if we are using bigger pipes? And it's very nice to observe that especially in the big cities, the actual pipe costs have little or limited influence on the total capex. If we look at an example from Copenhagen area, we can see that the capex go up with 3%, whereas the flow capacity goes up with 40% if going one dimension up. So it's actually not so expensive to do it, and the reason is, of course, that there are so many other costs involved, and we are looking at capex for pipelines in large cities. So you get actually bang for the buck. But what is the current situation? We have the pipes that we have, right? And it is not easy to change the pipes that is in the ground, except if you, for example, want to get rid of some of the true bottlenecks. That is, of course, something that is valuable. But if we change the main pipes, what then? I would say my advice will be consider to use larger dimensions in general, but especially in the cities. Also, if dimensioning new network, always consider using larger dimensions. we have to go down in temperatures, and that requires bigger dimensions. And think ahead. Remember to include all the developments in the cities and so on. And then, why? I have made one provocative example, and I will run through it very fast. For example, if you have a temperature regime of 90 to 40, you have the expenditures on the right side, and it's 338 million. Thank you for pointing out there, Morten. And if you use a low temperature regime of 65/40 degrees, you would only have 250 million kroner a year. And remember, this is a very rough estimate, but there is this clear tendency. You have very big savings when using heat pumps with lower temperatures. And these savings actually, if you look at only a 20 years period, would be as much as 1.8 billion Danish kroner, or 240 million euros for you who know that currency better. So think about it. There's a lot of money to save, and therefore also something to think about when using bigger dimensions. So to sum it up, why lower temperatures and why bigger dimensions? We have to use lower temperatures so we can incorporate heat pumps in the district heating network, and we get the better COP. And of course, incorporation of district heating or heat pumps in the district heating network is something that we need in many ways. Incorporate low temperature heat sources like geothermal energy, data centers, waste heat, and such. Also necessary, and something we do with using lower temperatures. Lower the heat losses. That is something which has been essential in the Danish transition, but actually now we have low temperature networks, and that gives money on the bottom line every year. So that is nice. Also, expand the lifetime of the pipes and the insulation, brings you lower capex and opex. And you can use cheaper materials in general. I think there will be many new inventions to come for new pipe systems. We can use plastic in many ways, where we used steel before. And also remember that lowering the flow and return temperatures, because the return temperature is essential because it can create more room and therefore more space for lower temperatures. And of course, the last thing, get a hold on the boundary conditions and do your hydraulic analysis. And this is something that comes because I have done that for many years, so I know how important it is. So I guess I am through now, and I hope I didn't overrun the time very much. So I would say thank you for your attention, and bigger pipes, yeah, that's the way to go. Thank you.
Thank you very much, Thomas, for this presentation. I feel convinced at least.
Yeah, I hope so.
Next one, yeah. And the next presentation is from Peter Jorsel. You have a nice picture of Peter here. By the way, I noticed nobody is typing any questions, and I know Thomas is an excellent presenter, but come on, Anthony, Andrew, David, Stephen, Victor. Some of you must have some questions you are dying to get answered by these experts. And all the rest of you, you are also very much welcome to type in a few questions in the chat. Okay, Peter, unmute your phone. Thomas, mute your phone. And are you ready, Peter, for your first presentation on total cost of ownership?
I'm
because
ready.
it's all here for you now. Please go.
Yes. Thank you, Morten, and thank you to Thomas, because now you have made the advices to make the right hydraulic design of the pipe system, and I will take over and talk about what kind of pre-insulated pipe systems you can use in the best way. So first I will set the stage for the further presentation. There are a lot of available pipe systems, pre-insulated pipe systems for you. There are pair of pipe and there are twin pipe, and for both pair of pipe and for twin pipe, we have three different insulation series. So that make 6 different choices on the same project. Then we have a possibility of having pipes with a diffusion barrier, and you can have pipes without a diffusion barrier. And the diffusion barrier will secure that the heat loss properties of the pre-insulated pipe network will remain the same during the whole lifetime. So all in all, that gives 12 different possibilities for the same project. So the markets for pair pipes look like the Europe maps that you can see here, and the size of the circles kind of indicate the volume. And if we look on the share between the different series, then series 1 pair of pipe is approximately 60% of the total market of pair of pipes. And that said, then series 1 pair of pipe is the pipe system with the worst insulation properties. So 60% of the market actually use the pipes with the worst insulation properties. If we take a look at the twin pipes, then twin pipes will represent approximately 35% of the total sales in dimensions where it's possible to make twin pipes. In Denmark, that figure will be 70%, and in Poland it's around 5%. That said, the lowest possible heat loss in a pipe system will be with twin pipes. And then a provoking statement. We still see many energy companies that actually make the decision on which pipe system they should choose on we do what we do because this is what we always have done. And not necessarily the right way to do the choice. There was a clever person, Warren Buffett, who said, price is what you pay, value is what you get. And this is actually very much about my presentation. That is that the extra investment you will do in getting some values, you actually will see that you will have a return of that payment. So that is what it is about, to make the right choice. Okay, the right choice of pre-insulated pipe system based on the total cost of ownership perspective will be in the next part of my presentation. And first, shortly about what is included when I do the calculation of total cost of ownership. So on the CapEx side, the investment side, it's the pre-insulated pipes, investment in the pre-insulated pipes, investment in excavation and asphalt work, and investment in handling of pipes, welding and jointing. I have not included the investment in consulting and the work that Thomas is doing for the design and the supervision. For the, oops.
Sorry,
Okay.
Peter. I don't know what happened, but you're back now, and we can hear you.
Yeah, okay, super. For the OPEX part, so the operational cost, I have included the heat loss cost, but not included the pumping cost because the hydraulic design has been taken care of, so it will be the same for the different pipe scenarios that I will compare. And repairs, maintenance, surveillance is not included either. So this is what I include in my calculations. Okay, then I will dive into the investment of the pre-insulated pipes. So if you look on the investment in pre-insulated pipes, then it's a fact that twin pipe is more expensive than pair of pipe. If you go one insulation series up, for example, from CS1 to CS2, then the additional cost will be around plus 15%. It is a fact that if you use joint solutions for doing bends and tees and reductions like shown here on the bend, where you make a joint solution instead of a pre-insulated fitting with two straight joints, then you will have a saving compared to doing the pre-insulated fittings part. As well, there will be a saving on doing curved pipes compared to the pre-insulated pins and straight pipes. Always choose an active surveillance system where you will have an immediate message if moisture is going into the insulation, so that you can also react on that. Okay, then I'll dive into the investment in the installation. When we look at the installation of the pipe, so the handling of the pipe, then twin pipe is often considered difficult or even impossible to weld in countries that are not used to do it. This is not the fact, and the experience from countries like Finland, Sweden, Denmark, where they do a lot of twin pipes, is that it is as easy to weld on twin pipe as it is on single pipe. So the message here is that the energy company must set the agenda themselves. It is not the installer who should decide what system to choose. It will actually be an easier handling on the twin pipe system, as you only have half the amount of joints and you only have one pipe. So all in all, you actually have a 15% saving on installation cost when you do twin pipe compared to if you do pair of pipe. If you go one installation series up, for example, from CS1 to CS2, then you'll have a 2% increase on the installation cost. And again, you will have a saving on doing joint solution on bends and tees instead of doing the pre-insulated solution with fittings and straight joints. If you look on the investment in, if you look on the investment on the, so now I clicked something I should not click. Morten, maybe you should help me. If you look on the investment in excavation.
There is something wrong. We can only see this, Peter.
Morten?
Yes, I'm here. What is it?
Yeah. My picture is changing all the time now.
You're clicking something. I don't know what it is, but you can still change your slides. Please bear with all the details around the slide, but we can still see the slide, Peter.
Yeah.
No, we cannot.
I moved forward once.
Okay, it seems like it's changing by itself.
Yeah. I'll find out how to stop. No, it shouldn't. Sorry. It's not changing by itself, but you can go back and forth with the same as you did before, Peter.
I do, but it changed by itself on my screen. Okay.
I think that is stopped now.
Oh. So I'm on the slide where you see investment in excavation, and here you will have the 10 to 15% saving on the trench and the asphalt work if you do twin pipe compared to single pipe. Approximately, you'll have a 2% of between 2 and 5% increase in excavation cost when going one insulation series up, for example, from CS1 to CS2. If you do joint installation instead of pre-insulated solutions, then you will also have a saving on the excavation cost. So now it seems to be right. And also when you do curved pipes instead of pre-insulated bends, you will have a saving on the excavation work. Okay, now it works. Okay, Then to the calculation on total cost of ownership on 12 different pipe scenarios. And I will look at a project like you can see on the screen, so a very simple project with dimensions between 32 millimeter and 80 millimeter. If we do the calculation of the total cost of ownership on the 12 different scenarios, then it's very important to decide the right assumptions for the calculations. So now we have actually fixed the investment part. So now we have to look at what has influence on the operational part. And the temperature that you see, that is the average temperature. That is important for the calculation of the total cost of ownership for the heat loss part. And then you need to decide on the period you're calculating on. So in this example, 30 years I have calculated on, and you have the maybe most important factor, that is the price of energy, because that will be the price of the heat loss cost. So the black part of this figure is the cost of pipe material, the gray part is the cost of pipe installation, the green is cost of excavation, and the red one is cost of energy loss. So with the assumptions that I have showed here, then the right choice would be twin pipe CS2 with diffusion barrier. But when you do these calculations and you have decided your model for the calculation, then you always should do a different sensitivity analysis on the assumptions. And that is what I have done on the next slide. Here I have done again total cost of ownership calculation for 12 different scenarios, but with some other assumptions. And the assumptions that I have changed is the period of years, so changed to 50 years, and the price of energy. And with these changed assumptions, then it's twin pipe CS3 with diffusion barrier that will be the right choice of pipe system. So when you have the model, that is actually the advice. When you have the model, then do different assumptions or different sensitivity analysis on the assumptions to see what will have of effect on the calculation. Okay, so now we have decided on the pipe system, and then you have to think about how do you secure the assets that you will put in the ground and which you expect actually to have a lifetime of probably more than 50 years. So first of all, you have to think about which products to choose. So you have to choose, for example, joints that will have a very long lifetime as the remaining part of the system. Very important point is that the fitters that is going to install the pipe system will be educated to do what they are supposed to do. They will be certified to do that. So when you have done that, then you have to require what is actually your demands to the work, and then you have to supervise that they do as they are expected to do. So supervision is extremely important. About the surveillance system, then always choose an active system so that you will have the immediate information if something is wrong, and you can react and make sure you react in time. You have to require what is the terms when the installers hand over the system before it's taken to operation. By doing this, then you will have a system where you will have a flawless operation, and you will secure you won't have any unforeseen expensive repairs and any breakdowns on the system. If you don't do this, if you don't train the joint fitters, if you have less focus on supervision, and we see this, and if the surveillance system is chosen as a passive system, so no focus on handover terms, then it might result in that you will have some unforeseen and expensive repairs that are, worst of all, not detected in time. And then it will be expensive, there will be the risk of a breakdown, and the lifetime will not be as you probably expect it to be. Okay, that was actually the part of the presentation about the total cost of ownership perspective. So Morten, you should now go to the next presentation about the total cost of investment.
I will do that. In the meantime, I'll just downgrade you from host, meaning you have the same powers as I have, and presenter, because then that interruption we had in with the slides should stop. So, Peter, there was a question about the two-pipe assembly and heat loss, but we will save that question for the panel debate. I hope, Elliot, you're all right with that.
Yes.
And the next, now from total cost of ownership to total cost of investment. I think most of us can kind of guess the conclusion, but Peter, give us the details.
Yes, so now we have been through the total cost of ownership based on the right choice based on total cost of ownership, and now I will take you through the investment if it's based on total cost of investment. So when you choose this method for your decision of a pipe system, then you will focus on the capex, and you will focus on minimizing the capex most possible. And then it is actually predefined that the choice of pipe system will be with the lowest insulation thickness, both when it comes to single and when it comes to twin. So it will be CS1 insulation. There are some things that is actually the same for total cost of investment and total cost of ownership. And for example, joint solutions instead of pre-insulated fittings and curved pipes instead of pre-insulated pins, that is actually also valid when you talk about total cost of investment. It was also valid for the total cost of ownership perspective. So it goes for both methods. But when you talk about total cost of investment, then probably you will not invest the needed amount of money in securing that your fitters are trained to do what they should do. And same about supervision. You will minimize the supervision part of the project. Probably you will choose a surveillance system that is passive, and with a passive surveillance system, you only get a status of the pipe network when you go and measure. So some will measure this maybe once a year, and we actually see some that actually never measure on it. And then you only will get an indication about the status when you have a failure. And a failure that is a big failure with leaking water. So when you calculate the 12 different pipe scenarios, when it's based on total cost of investment, then you actually take the heat loss out of the equation. So here I have put the price of energy to 0. So I only have the capex part as part of this. The right choice of pipe system doing this will be actually a twin pipe CS1 without the diffusion barrier. So actually, even you think about only the capex and minimizing the capex, you're actually helped a little in way of also thinking total cost of operation, because you are directed to the twin pipe system, where you actually have the better heat loss properties compared to the single pipe. So you are helped in some way in the right direction, but not the whole way. So if I should conclude on the total cost of ownership versus the total cost of investment, then basically we have 12 different choices of pre-insulated pipe system for the same project. And the best choice is based on an evaluation on with the assumptions that are valid for the energy company and for the specific project you are looking at. And then you should look on what is the sensitivity for the result if you change the assumptions. That's the way to do it. The choice of pipe system based on we do what we do because we have always done it. That is, in my eyes, a no-go. The perfect choice of pipe system is always done according to TCO calculation with assumptions that is valid for the energy company and for the specific project. So it could be general assumptions for the energy company, but it could also be specific assumptions for a specific project. And then when you are looking at total cost of ownership, then you you should be able to look long-term on the investments. So the bang for the buck, as Thomas expressed, that is that when you look at the lowest total cost of ownership, then you actually also will have the best financial impact on the long run. You will have better insulated pipe systems, and that will result in lower CO2 emission. Actually also something is very much in the discussion nowadays in the world. And you will secure an operation of your system without unforeseen failures. And if you have some failure, then you will be able to react in time. And you will make sure that you will have the expected lifetime of the system. Okay. That was it from my part with some short interruption, but I hope it was okay.
It was okay. Thank you very much, Peter. Great that we had this discussion. Total cost of ownership, total cost of investment. There are some questions, but I think we'll leave that for the panel discussion. Some of them are relevant specifically to this topic, but some are maybe a bit off. But before we jump into the discussion, I would like to invite Chris Hill. Chris is the Managing Director of Loxter UK. You have some UK experience on this. Look at the nice picture of Chris here. Are you ready there, Chris, for your few slides? You have a few minutes to update us on what is going on actually in the UK. Please go ahead.
Yep, sure. Thanks, Morten, for the introduction. You'll all have to excuse me a little bit. It's this time of year and I'm suffering from a bad case of man flu, as we call it in the UK. So, good afternoon, everybody. I'll just wait for the first slide to load up.
It's here. There you go.
Okay. Yeah. So, following on from Peter and Thomas's presentation, I'd just like to start by setting the scene for the UK market in regards to the total cost of ownership and UK guidelines. I've been with the UK in the UK market now for Loxter for 6 years, so we have a little bit of experience in a relatively infant market. As you can see, the graph on the right, this is an indication of the projects delivered into the UK over the last 12 months. So you can see there is still a large concentration of networks in London. However, networks are developing in cities such as Birmingham, Leeds, Bristol, Manchester, Nottingham, Sheffield, etc., just to name a few. From these projects, we can see that the twin pipes represent less than 10% of total pipe sales. And within the twin pipe sales, 7% is Series 1, 65% is Series 2, and 28% is Series 3. And for the single pipes, the percentage split is 28% in Series 1, 43% in Series 2, and 29% in Series 1. So therefore, in general, these statistics do show the UK is working towards developing the networks with higher installation series and twin pipe systems using the TCO evaluation. However, work is still to be done. Excuse me. In the UK, when discussing total cost of ownership and guidelines, a document has been produced in 2015 by consultation by various organisations, which has been headed by CIBSE, which is a Chartered Institute of Building Service Engineers, and this is called the Code of Practice. This is a guide to setting minimum standards in heat networks. Included within this document is life cycle cost evaluation, and actually in the code it states in Objective 3.6, to achieve a low-cost network, optimisation of routes and pipe sizing for minimum life cycle costs should be considered. Within the UK, there's various stakeholders within the district heating sector. You can see energy companies as the pipe owners or maybe local authorities. You can see developers, contractors and consultants. So if we just break down these individually, we can see how these various stakeholders act in relation to the TCO evaluation. Energy companies / local authorities who are pipe owners, they do consider overall life cycle costs. However, a deciding factor in the UK is still CapEx. The developers, this sector is very much driven by planning policies to install networks in the first instance, and CapEx is a key driver due to short-term ownership. For future consideration, maybe, of TCO in this sector, adoption and specification by energy companies and consultants will help bring the insulation levels to a higher standard and potentially the use of twin pipe systems. In the consultant area, they do primarily design projects based on client requirements, and this could be TCO or CapEx. However, what I see in the UK is that the insulation series is usually series 2 for single pipes as a minimum, and twin pipes are also considered. And then we have the contractor market, the installation market. They think about CapEx as a driver, unless the specification is tight, and how easy it is to install the system. Therefore, twin pipes can sometimes be seen as too complicated to install. But, as Peter mentioned, in other countries, specific training can improve this misconception. Excuse me. So, UK market as a TCO perspective, in conclusion, from the various slides you've seen today, the UK perspective is very varied. Customers do use all 12 possibilities for the pipe systems, as Peter explained, in twin pipe and single pipe. And around a third use either twin or a pair of pipes in Series 3, but less than 10% use twin when twin is used. It is mainly Series 2 or Series 3. And around a third of a pair of pipes in Series 1 is still used, which is the worst insulating solution. So a quick conclusion with all those numbers is that a choice of a pipe system based on TCO evaluation in the UK is approximately 36%, and this is used in Series 3 in a pair of pipes, 2 singles, and or various series of twin pipes. Conclusion for the code of practice. Currently the UK code is seen to be used as a guideline, not a policy. The code is not intended to provide general design guidance, rather it aims to set minimum standards, and still the overall responsibility for implementing the code still rests with the client. There is an update on the code of practice currently under review, and hopefully we will see this issue to the market in Q1 of 2020. So I guess to put a question out there, how do we get to a situation in the UK where we can actually influence the code of practice to take it from a guideline to a standard, which then will hopefully include TCO evaluation. That pretty much wraps me up for now, Morton, so I can have a good cough.
You can. Sorry to hear you're hit by man flu. There is a tiny, but definitely there is a chance to survive it. It'll be a tough few weeks. But you will manage, I know. Okay, thank you, Chris, and for this. Let me just, now we have you. Chris, it looks like the UK understands this a bit bigger. Peter said early on that there's a tendency to do what we have always done. And I think it was Einstein who said, only idiots repeat the same action and expect a different result. So that is talking against do what you always have done. Why is it that the UK is better than many other places? Because some of the other places have more district heating than the UK, but not a lot. It's not like mature markets. Is it just because they have a clever managing director at Lockster UK, or could it be something else?
I think that does help. No, joking aside, I think the UK is still relatively in its infancy for district heating networks. We have some old systems in the UK, Nottingham, Sheffield, Leicester, etc. But over the last 5 or 6 years, we've seen a lot of guidance from Scandinavia, especially Denmark, and a lot of engagement with the UK stakeholders, absorbing the information from other countries that have actually got experience in overcoming issues maybe that they've encountered over the last 20, 30 years. So I think we're actually learning our lesson before we actually have too many problems. So they're already looking at making systems better, and part of obviously that is the TCO.
Yes. Okay. Thank you very much. I'll save the questions because they are fairly specific and detailed. So I think I'll save the questions for a bit later where we have a more open debate. But Thomas, you had one I will bring up anyway. Length, lifetime of the system. Thomas, please elaborate a little bit on that, and then we look forward to hearing Peter and maybe also Chris on that question. Go ahead, Thomas.
Yes, one of the things that is, I think, crucial when you're thinking about new district heating system, that is the lifetime of the system. Because, you know, we used to, in the old days, to consider 20 years as the investment time, but the lifetime of a piping system is much longer. And we know from what we've seen that many pipe systems that are even 50 years or more are still functioning and are still pretty okay. So what should be the lifetime, and what should be the, you know, the year span you're using when collecting total cost, Peter?
Go ahead, Peter.
Yes, that's a very interesting question to debate. You can say the standards for the pre-insulated pipes actually define that minimum lifetime for a system that is operated with 120 degrees Celsius continuously, and every year up to 140 degrees, 300 hours a year. That will happen every year. Then it shall have a lifetime minimum of 30 years. And that is what the pipes and the fittings and the foam system and everything is designed for. So then when you do not operate at these conditions and you operate at lower temperature, then the lifetime actually increase exponentially. So if you start calculating the lifetime for the foam, it will be lifetime that is very theoretical at very low temperature. So it easily gets up at many hundred years of lifetime. So and the same will go for the static and the fatigue of the steel. So consider that the installation is done in the right way, joints are installed in the right way, and no mistakes is done. Then lifetime will at least be more than 50 years, and that's very conservative set. So theoretically, much longer.
Thank you, Peter.
And theoretically, it can be calculated, but it gets very theoretically.
Mm-hmm. Okay, but now you have this standard, and it says if you use your pipes to that extreme, and many systems today will never get into 120 and 140 is so off limit. But is it actually something you developers of district heating system will accept that you say this, that it's much longer? Because it's not written anywhere. It's not within the guarantee, I'm guessing.
No,
that was the question for Peter. Okay. And for Chris later on. How do you convince, what is it that or does the UK market do this? Do they have a longer time, lifetime or depreciation time on your pipe when you do the calculation? First Peter, then Chris.
Guarantee is another question, but the calculated lifetime is very long. And what we see energy companies that is actually evaluating on the total cost of ownership doing is that they are calculating now on 50 years. Earlier, it was calculated over 30 years, but now they start to calculate over 50 years, and some even on 70 years. So they do actually total cost of ownership calculation based on more than 50 years lifetime.
That's quite impressive, 70 years.
Yeah, and
okay.
I agree with Peter that we see 30 years as a minimum standard basically, but people are already looking at 50 years, and some companies have actually put in 50-year installation warranties against it as well. And we do have energy companies in the UK that have got projects that they are operating and maintaining for 70 years. So they are building or looking at building systems for that longevity.
Just staying in the UK, I have a small anecdote. I won't mention the city, but They actually had pipes. I can't remember if it was Lockstop pipes or not, but it really doesn't matter. And they had a built-in surveillance system in these pipes. They actually paid extra. But somehow they forgot to train the welders and the people doing and the joints and so on, that you need to connect the surveillance system to make it actually work. So there's a surveillance system in all the pipes, but it's not connected. Just giving you one more example of probably it's a good idea to train your welders and other people around you. Peter, you asked Thomas a question here. What is your perspective on having smaller size on pipe on flow and return?
Yeah, smaller on flow than on return.
Yes, exactly. Thomas, you said bigger is better, bigger is better, bigger is better. So, but what about these? What do you think, Thomas? Do you have some comments on this question to the design of your pipe system? I think you're speaking, Thomas, but you're muted.
I'm here. I have this comment on this with having different sizes in flow and return. And I would say, really, I don't think it's a good idea because it complicates the calculations and also, really, when you go down in temperatures, there's not that much difference in heat loss. Also, because the flow through the pipes are much faster. So you will have a lot of water going in, and especially the idea of making a smaller pipe, I think it's kind of obsolete. I don't think that will get any points in my review. I would like to go with the normal way we have done it. I think the beauty of having district heating is actually that it's so simple because it's just warm water in pipes. And it is something everybody can understand. If you start to make all kind of technical solutions and so on, you try to complicate things. So I would stay with the dimensions should be the same. One practical example: I'm working for a company in another country, and actually they don't know what is forward and what is return. So they could actually mix it up. So they could make the big one for the flow and the small one for the return. I mean, there are so many errors that you can make, so let's keep it simple, all right?
And I think with that we will end the formal part of this discussion. There's still a few questions from Elliot and from Stephen that we will discuss in a few seconds. Now, I would like you to rate the webinar. You can see that is in the bottom right part of your screen now. It's also, of course, only allowed to do what one just did, say it was great, very interesting. All the others you don't have to vote. Now, I'm just joking, but you can. And then if you would like to get the article from Peter, Secure the Assets in Your District Heating Network, and of course sign up for the world's best district heating magazine, that's our magazine called Hot Cool. Type your email address just above that. Now, the formal part of the webinar has finalized. More questions and comments will follow right afterwards. I would like to thank the many participants who found their way into this pipe network discussion webinar. And I would especially like to thank Chris, Peter, and Thomas for providing some excellent presentations. With that, formally, we close down now. And in the same second, we open up for, as you would in any other seminar, live seminar, now we are all standing to talk in details to the presenters. So let's go for that for a second. And the first question, Elliot, you asked, is there heat loss from flow to return in the two-type assembly itself? Essentially, you have a counterflow heat exchanger, he says, To what extent is this? And is it included in the calculation of heat loss? I'm guessing that that might be you, Peter.
I'm guessing the same.
Good.
Yes, there is. You can say there is a heat loss from the flow to the return. The heat loss that I have calculated here, and the heat loss that we calculate in our heat loss calculation programs, that is the external heat loss. So that's the heat loss to the surroundings. So the heat loss that stay in the system, and the heat loss you don't have to spend energy on heating up again, that is not included in the heat loss calculation. So only the external heat loss is included. It is possible to calculate how much is the heat loss from flow to return, and it of course has some effect back on the production plant. Depending also on size of pipe and dimension on insulation area, but it can be calculated. A thumb rule actually says that the return temperature will not decrease because of the heat loss. It will stay the same back on the plant. But can be calculated per dimension, and Elliot is very he can take contact to me, and then we can have a further discussion about it, and we can calculate examples of this.
Elliot, I can't see if you already shared your email, but do that so that we can contact you with. Okay, you said okay. Thomas, you said, is that Excel sheet made available? I think you mean the Logstor calculator. I think it's a bit more than the Excel sheet, than an Excel sheet. But Peter, that is ready available for everyone, or how is that?
The Excel sheet is not ready yet, but it will be come to our homepage in a spreadsheet version.
Okay, good. And
Thank you.
kind of when do you expect that?
In beginning of new year.
You will send an email to everybody who signs up here about that, so
Sure.
They will have it, and
Yes.
you will post it also on DBDH website when we get to
Yep.
that.
Yes.
Stephen Hart, how are you, Stephen? I hope you're well. He asks how much additional pressure losses should we allow for insulation valves and fittings in the distribution pipe network? Is the cost of pre-insulated valves and fittings significant for the investment cost? Again, Peter, Chris, but maybe also you, Thomas, know a bit about that.
Yeah, I couldn't.
In somebody.
Yeah, I would like to do it.
Yes.
Yeah. Normally, when we do the calculation of distribution networks, we have an extra set aside of 15% for bends and for valves and for different things that can occur in the network. So I would say when you calculate, put aside 15%, and then you're safe. There are numerous companies that produces valves with, what we call full bore, and depending on the situation, I will not say that these valves cannot be worth something, but that is not the normal. Normally, you have a heat or a pressure loss because of the bore is not 100% because you use cheaper valves. So I would say 15% in addition to the calculated pressure loss according to Coolbrook and White, for example. Does that answer okay? No problem.
Yeah, and I have no further comments to this because this is about the hydraulic design. So Thomas is the expert.
Thank you, Peter.
Okay. And Morten, you are muted if you say anything.
Thank you very much. I've asked several questions and wondered why nobody wanted to answer them. But here we go. Peter, series 1, 2, and 3, different ways of insulating your pipes and also with diffusion barriers and so on. I think it's two different questions. One, series 1, 2, and 3. Are there situations where we should probably choose a series 1 and some where we should definitely choose a series 3? I think diffusion barriers is a different part of that, but is it?
No, I think it's all in the same question.
Okay, go ahead.
I would like to say that you have to base your decision on calculations. So you owe yourself to do the calculations and then make your choice based on the calculation and based on the assumptions that you have done. So I really don't want to say that in these examples it's always series 1 or series 2 or series 3, because then I very much tend to do what always have been done. So my advice is really to say, do the calculations. I could say that for very big pipelines, then normally it's more difficult to calculate an interesting return of investment with very high insulation thickness. But my advice is always do the calculation of different pipe scenarios and then do your choice. And do really spend the time finding the right assumptions.
Now I have done that, Thomas, and I have a big pipe. Oh, Peter, I have a big pipe network, and I've calculated and calculated and calculated, and it comes out to be series 3, series 3, series 3. And I accept the calculation. I fully know that, but then I look into my pocket and find not enough money. So if I can't afford to go only with the total cost of ownership, but actually also have to look at total cost on investment. What then? Is there some solution in between, or what do you recommend there?
Actually, there might be a solution in between, because the total cost of ownership that I presented is very much to the one side in the window where you can make decisions, and total cost of investment is very much to the other side. But there might be a solution in between, and then you can see, okay, what if I calculate this on a 15 years period? What will then be the proposal for the choice of pre-insulated pipe system? And then you can see, okay, will I have money for this or not? And then you have to again, if not, then you have to do another calculation with a shorter period. And the shortest period you can calculate that's 0 years. So it will be in between, but you need to do more calculations then. And then the advice will always be, always remember, no matter what kind of system, if it's really total cost of investment with series 1 pipes, do the training of joint fitters, do the supervision, and choose an active surveillance system. Then you are sure to have a flawless operation of your pipe system.
Good. And Jacob is asking a question here. Is there any notable difference in heat loss in the overall system between liquid foam and half-shell joints? And also, if you look at it over the lifetime of the system.
Yeah, and that's for me. So the best insulation properties in the joint you will have with a joint that is foamed on site. So you will have a lower heat loss from a joint foamed on the side compared to a joint with insulation half shells, and it has something to do with the, you can say, aging of the foam, and the half shell is more or less fully aged when it is installed. So you will basically have the worst insulation properties in insulation half shell. So recommendation is, on that perspective, from a heat loss cost perspective, then it's do a foam joint.
So you didn't exactly answer if there's a notable difference, but my interpretation was, yes, it is actually something that you should take note of. Is that correct?
Yep.
Thomas, can't remember who mentioned it, but Peter, it was Peter mentioning in his calculation that if you're not afraid of heat losses, you will also, of course, set the value of your heat to 0 when you do your calculations. Do you see that when you talk to cities and district heating companies all over the world? Is heat loss not really important to most, or am I totally wrong here?
No, definitely not. I mean, the wind of change is blowing, and you know, as I said, maybe we tend to see a more holistic view on everything, and especially everybody knows now that heat is generated somewhere, and normally it has something to do with CO2 and so on. So minimizing the heat loss is actually something that is very interesting. So we are going to minimize. And one of the things that Peter said was that, you know, the worst series used represent 60% in some countries. And I guess these countries, and I don't know it, but I guess these countries are countries where you use cheap fuels. And of course, if you use cheap fuel, especially, for example, coal or something like that, then the heat loss is kind of indifferent because the price of the heat is so low. So in order to get things going, you have to think about being green and also to you know, increase the price for those who transport the energy, because there's a big difference on the energy you pay for and the price you pay for the production. So sometimes, well, the production is too cheap, so you actually waste a lot. So it's like, you know, when you're producing gasoline, to produce 1 liter of gasoline costs 1 liter of gasoline. So, and it's incredible, right? So, yeah, that is just my meaning. So, yeah.
Thank you, Thomas. I think also if you look into the future, the idea of, even if you have enormous amounts of surplus heat from a refinery or somewhere, that may change. So going towards 0 in your heat price, because you don't think heat loss is important, is something that can and most likely will change before the lifetime of your pipe is over, and that is, as we heard, maybe 50 years from now. So we really have to be careful when we look at our heat sources and how we price them today and in the future. Well, I can see one question left that was from, just give me a second, somebody asked about the training. David, you asked about the training. If I have missed one question you have typed into the chat, please retype it now. Otherwise, this may be the last comment. Peter,
Yes.
do you do training? That was the question from David.
Yes, we do training. We do training on installation of our different type of joints in our academy, and you can actually see the details for that on our homepage, or you are most welcome to take contact to me on a mail, and we can have a discussion about the possibilities. We do not do training on how to weld on the steel pipe. How to weld on the steel pipe is training in other places and has been there very well specified for many years. But actually what we are preparing now is a video about how to do the welding on a twin pipe, because we see in many countries that are not used to it, as I also explained, that they think it's almost impossible. And therefore we are preparing videos out from the trench where they align the pipes, they do the welding and different welding methods. And that video will be, when it's ready, and that will be very soon, then it will be ready on our homepage as well. Not said that we do the training on how to do welding on steel, but we can show how it's done and show that it is not more difficult than doing the welding on the single pipe when you have the right tools and know the small tricks that are needed.
Okay.
I hope that answered the question. Or otherwise, David is very much welcome to take contact to me.
think David is writing back either. Yes, it did. Thank you, David. Good to hear from you again. I think this is now the conclusion. Hurry if you have a last minute question you just came up with now. Otherwise, I'll start my thank you round once again. Thank you for all the participants. Thank you for hanging around here for almost 1 hour, 15 minutes. We did manage to keep the real webinar within the 1 hour session we did. Also, thank you to Thomas, to Peter, and to Chris for contributing to all the good knowledge you shared. Last chance to type in your email if you want more information from our side. And thank you for the 84.2%. It was great, very interesting. And also thank you to the 15.7% who said it was okay. But even more thank you to could have been better. There was none there. So, okay. Thank you very much, everybody. We will close down, mute ourselves, and the webinar will close in a few seconds. Thank you. And
thank you. Bye-bye.